Hello there. This time we're going to have a look at another paper from AQA's new 9 to 1 GCSE Maths. This is from practice set 3 and is a paper 2 paper. And so this one means we can use a calculator to do all the questions on this paper, which I'd recommend doing for most, if not all, if you're unsure. Anyway, let's have a look at the first question. So question 1, we're asked to circle the cube number. Now, a cube number just means any number, any whole number, multiplied by itself 3 times in a row. So, for example, the first cube number would be 1 times 1 times 1, which is 1 cubed. The second cube number would be 2 multiplied by 2 multiplied by 2, which is 2 cubed, and so on. The third cube number would be 3 multiplied by 3 multiplied by 3, and we can just keep going. But for this question we don't need to. As you can see, these numbers are relatively small. And so what we can try for each one is using the power button to the power 3. 1 cubed will be 1, but 2 cubed, 2 multiplied by 2 multiplied by 2, will be 8. So because 8 is in our list, 8 is the one we circle. So 8 is a cube number, it's 2 cubed. Question 2. On a circle, which of these lengths is the longest? And we need to circle the answer. So we've got different parts of a circle. For this question, I thought it would be worth reminding you of all the different parts of a circle, all the main parts of a circle. So I've got a circle here, pre-labelled. So the radius goes from the middle to the outside. The diameter is double the radius, it goes all the way through the middle from one side to the other. A chord is just any line which joins, any straight line which joins 2 points of the outside together. But the circumference is this line all the way around the outside of a circle. So the circumference of a circle is basically the perimeter of a circle. It's all the way around the outside. And so for that reason, the circumference is longer than the radius, the diameter, or any possible chord, because it's the whole way, all the way around the outside of the shape. So circumference is the longest, which is why we need to circle that one. Question 3. Add -5 and -3. Circle your answer. Now, with a calculator paper, there's no excuses for getting this one correct. Minus numbers on a non-calculator paper can be a bit trickier, but here, because we've got a calculator paper, it's very simple. So we just take the two numbers, -5 and -3, and add them together using the calculator. So the first number, -5, plus, add, -3, you'll get -8. The reason for that is, if you've got two signs touching, a plus and a minus, or a minus and a plus, if the two signs touching are different, if they're mixed, it makes it a minus overall. So this is the same as taking away 5, then taking away another 3, which is -8. But anyhow, the answer would be, for this one, -8. And so this is the one we need to circle. Question 4. Circle the unit of mass. Let's have a look what all these are first of all. So we've got a few different units. Got millimeters, grams, litres and degrees. Millimeters, if you have a ruler in your exam, which you should do, that's on your ruler, it's a unit of length. Grams is the unit of mass, and so this is one we need to circle. But just carrying on anyway, litres is a unit of capacity, usually used for liquids. So it's like how much water is in a bottle, for example. And degrees could mean one of two things. It could mean a measure of an angle, or degrees could be measuring temperature, but obviously you should specify whether it's degrees Celsius or degrees Fahrenheit. So the only one it must be is a unit of mass. Question 5, a slightly trickier one, given by the fact it's 2 marks, not just 1 like the previous ones. Write down all the whole numbers between 91 and 120 that have exactly 2 digits the same. So what I'd suggest we do is just write down all the numbers between 91 and 20. 91 and 120, pardon me. So what we're after here is the numbers which have exactly 2 digits the same. So perhaps a slightly long way of doing things, but this is probably the safest bet to make sure you don't miss out any numbers. Then 110, 111, 112, 113, 114, 115, 116, 117, 118, and finally 120. So what we're after here is numbers that have exactly 2 digits the same. It doesn't mean 2 or more, it means exactly 2. No more than 2 digits which are the same, no less than 2 digits which are the same. So 91, all digits are different. So I'm just crossing off the ones where all the digits are different. We have a look at 99. 99 does have 2 digits the same. The 9 and the 9 are the same. Same with 100, it's got 2 zeros. 101, 1 and a 1, they're both the same. Then 102, again they're all different. Same with 103, 104, 105, 106, 107, 108, and 109. But then we get back to 110, and that does have 2 digits which are the same. Now 111, this is where a lot of mistakes are made. 111 doesn't have exactly 2 digits the same. This one here has 3 digits which are the same. So that one doesn't qualify. It doesn't have exactly 2 digits that are the same, it has 3 digits. And so for that reason we can't have that one included. However, we can have 112, 113, and the other numbers here because they both start with 2 ones. However, we can't have 120 because in 120 all the digits are different. So have a look now at which ones, how many, have 2 digits the same. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so the answer to this one is the list of these numbers: 99, 100, 101, 110, 112, 113, 114, 115, all the way up to 119. And so that is the list of all the numbers between 91 and 120 that have got exactly 2 digits the same. Question 6. Katie is facing north and she does a 3/4 turn, pay attention, anti-clockwise. So first of all, it's worth paying attention to the fact this is saying anti-clockwise, which means this way round, the opposite way to the way a clock turns. So afterwards she then turns 135 degrees clockwise. So clockwise does mean like a clock. Actually this way around. So which direction is she facing now? And so first of all we can do her 3/4 turn anti-clockwise. So if she's facing north already, she'll be facing this way. 1/4 anti-clockwise, it'll be facing this direction. The 2nd quarter, she'll be facing south. The 3rd quarter, she'll be facing east. Remember, never eat shredded wheat. North, east, south, west. And so after she's done that turn 3/4 anti-clockwise, she'll be facing east. We can then have a look at the second part of this now, because after doing that she then turns 135 degrees clockwise. So 135 degrees clockwise is a 90-degree turn, then another 45 degrees. What it might be easiest to do though is just to use a protractor, which I've got here. And the way we do it is we measure the angle, we put the middle of the protractor over the corner of the angle, in this case over that dot, and then count from 0, start from 0 always, and count up until we get to 135. So this is 50, 60, 70, 80, 90, 100. 135 we should be able to see is just here. 135 between 130 and 140. So after she's done a 135 degree turn clockwise from east, she's facing down here now. So only thing left to do is just be thinking, what direction would that be on a compass? If you wanted to, a valid answer would be to give the bearing of what she's facing. What I'd suggest though would be to consider points of the compass yet again. So if that's north, that's east, down is south, to the left is west. And so what she's doing here is she's facing in between south and west. So that direction she's actually at now will be southwest. And so our final answer is that Katie must be facing southwest. Question 7, we have a bank statement with missing values. So we've got credit, debit, and balance. Balance means the money you've got right now. Credit means money going into your account. Debit, I always think of debit as the fact it can't be spelt without spelling the word debt. Debt is bad, as is money going out. So money out is debit, credit means money going in. And so we need to complete this bank statement now. So if we have a look at this one, the balance starts off at £37.60 and then jumps up to £324.85. The balance has gone up, so some money was paid in. So to work out how much money was paid in for credit, we can work out the difference in between these two values. So what we could do would be 324.85 minus 37.60. And we get 287.25. So just to remind you how we arrived at that one, we simply did 324.85 take away 37.60. Now on the next day a gas bill goes out. Bill means money's going to be paid out, and so £50 is going to leave the account, and so the new balance will be the £324.85 it was minus the 50. So this one here will be 324.85 subtract 50. Be careful when you're inputting numbers which are a mix of decimals and not decimals. It might be easiest to actually include the decimal in the 50 as well. So for this one here, the new balance will be 324.85 subtract 50. And we'd get £274.85. Finally, another bill goes out. This time it's council tax, and so the balance is going to be reduced by a further £61.84. And so the final balance will be the previous balance of £274.85 subtract £61.84. So if we work this one out, 274.85 minus £61.84, we'd get £213 and a penny. So that question's 3 marks. A mark is awarded for each correct figure in these 3 spaces we need to fill in. So those are the figures we should have arrived at, and that one's now done, question 7. Question 8, simplify. So this is an algebra one. Simplify means we group together for like terms. And so looking at this one, we've got 2 different like terms. We've got 3a, and this one here is a minus a. We always consider the sign in front of what we're dealing with. And if there's no sign in front, you can always assume it must be a positive. If it were a negative, you'd have to say so. So if it doesn't say, it will be an invisible positive. So one thing we've got is the a's. The other thing we've got is these b's. So we've got 7b here, which is positive, and another positive 4b over here. And so grouping them together, positive 3a, take away a, would leave us with 2a. Now the b's, we had 7b plus an extra 4b. That gives us a total of 7 plus 4, which would be 11 b's altogether. So putting these 2 pieces together gives us our final answer. And so we've got 2a, and we'd also have 11b. So the final answer for part A is 2a plus 11b. Question 8, expand these brackets. So expand just means we're going to multiply out what's on the outside by what's on the inside of a bracket. So the first one, 4 multiplied by 2d will be 8d. As we've got a plus sign in the middle, so put the plus sign down, and then 4 multiplied by 5 will be 20. And so this one is 8d plus 20, as simple as that. Just multiply everything in these brackets by 4. Finally, factorise. Factorise means put back into brackets, in case you forgot. The way we do that is we look at the numbers in front of each different group and we think, is there anything we can divide both these numbers by? So what can we divide 15 by and divide 18 by? What times table is 15 and 18 in? Well, these numbers here are both in the 3 times table. We can divide them both by 3. We then look at the letters. is there any letter common to each group. This one's an X, this one's a Y. And so because the letters are different, we can't factorise out any letters. So the only thing we can factorise is this 3. Once we've got everything factorised out that we can do, we then open up the brackets. By the way, just a little point, you're always looking for the biggest number that fits into both of these values. Not just any number, but the biggest. That's the difference between partially factorising and fully factorising. Anyway, going back to what I was saying, 3 fits into 15 and 18. The next thing is, we need to be thinking, how can I get from 3 to 15? What can I multiply 3 by to get the 15 that I want? What we'd have to do is multiply 3 by 5 to get 15. But because we've got an x at the end, we'll need an x here. Plus sign, so put a plus sign in. And again, do the same thing with 18y. We've got 3, want to end up with 18. So what do we multiply 3 by to get 18? The answer would be 6. 3 times 6 is 18, but we need 18y. So because we need to end up with a y, we need to include a y on the inside of the brackets. And that's the final answer. So it'd be 3 brackets 5x plus 6y. Question 9 is about pocket money for Jack and Liam. So they both get some pocket money, both get the same pocket money in fact. So we're told that Jack spends 75% of his, and he has £2 left. So let's just focus on this for a second. And so we're told that he's got £2 left. Not that he started with £2, but he's got £2 left over. And he spent 75% of it. So for Jack, if he spent 75% of his pocket money, what that means is we can work out what percentage he's got left. So before anything happens to an amount, we always start with 100% of its value. So if he spent 75%, that means he's still got 25% left. Because 100% take away 75% would still leave us with 25%. But we've been told that he's got £2 left, and so what we can say is that £2 must be 25% of the original pocket money. Another way you can think of 25% is that it's a quarter. So to go from 25% to 100%, which is what we want to find out, because 100% is the original pocket money, what could we multiply 25% by to get 100%? Well, we could double it to get 50, which should be £4. 50% would be £4. Now if we double 50%, that will give us the 100% we're after. Double 50% would be 100%, and if we double for £4, that would give us £8. And so the original pocket money they each had will have been £8. It says Liam spent 40% of his pocket money. And so Liam must have spent 40% of his £8. So on a calculator we can work this out fairly simply. 40% means 40 out of 100. So that's 40% of 8, which is £3.20. That's what he spent. He spent 40%. So what he has left is the £8 he started off with, subtract the £3.20 he spent. So £8 minus £3.20 tells us that he has £4.80 left. And so how much does Liam have left? The answer is he's got £4.80 left. Question 10. We have to draw two straight lines inside this rectangle to split it into one trapezium and two right-angled triangles. This is a hard question to know where to start, but what I'd suggest would be to focus on the trapezium. Okay, what is a trapezium? So what I've got here is a diagram of a trapezium. They can come in different shapes and sizes, but effectively it'll have a top edge and a bottom edge which are both parallel to each other. All the shape needs to be to make it a trapezium is two lines joining the top and bottom at either end. And so what we could do with this rectangle is fairly easily turn it into a trapezium by just doing one line diagonally up from one end and another line diagonally up from the other. And so what we've made here is two different trapeziums, because the first one I showed you, if this is a trapezium, then so is what I've just drawn on, because the bottom edge, the bottom here, is parallel to the top, and we've just got two lines, two straight lines joining the top to the bottom, and so that makes a trapezium, which is what we want to have. And if you look what's left, because I've left the top corners of a rectangle alone, these are going to be right angles. And so I've got my two right angled triangles left as well. One there, and a second one over there. And so that's one way we could just draw in a trapezium and two right angled triangles. And so we could sketch it here to practice and put the final answer over here. And so the final answer, just keep it simple, we could do the same thing on the final diagram. So there's a trapezium in the middle and two right angled triangles either side of it. You could do it a different way. You could do the trapezium going sideways. So that would be a longer, thinner trapezium on its side, and in this case the two right angled triangles would be over here. That's just another suggestion, but I think the easiest is to leave it like this personally. Question 11. Joe sold 132 mugs. So 1/4 of the mugs were small. So that's the first thing we've been told. So what I'm going to do is just further divide this page so we can think about small mugs and the others which were large. So small mugs. She sold 132 mugs, and it says here that 1/4 of them were small. So the number of small mugs is 1/4 of the 132 she sold. So you can work out a quarter of something by just dividing it by 4. Or we could use the fraction button on the calculator and multiply the fraction by the amount which we want to find that fraction of. So a quarter of 132, or 132 divided by 4, would give us 33. So there's 33 small mugs that she sold. Now as for the large, it says the rest were large. And so if 33 was small, we can recover the number of large by doing 132 take away 33. And that'll tell us how many were left. So 132 take away 33 is 99. So we've got 99 large mugs. So now we can have a look at the profits. So we've got small mug profits over here, which we can think about first. So it says that Joe made a profit of £2.45 on each small mug. So the total profit for the small mugs would be the profit per mug sold multiplied by the number of those small mugs she managed to sell, which is 33. So £2.45 multiplied by 33 will tell us the total of her profits for the small mugs. So £2.45 times 33 comes out to be £80.85. So for the small mugs, she got a profit of £80.85. We can now do the same thing for the large mugs. So first of all, we need to work out the profit per mug. And we're told here that the profit for each large mug, she made twice as much profit on each large mug. So the profit for the large mug will be twice as much as the profit for the small mugs, which was £2.45. So 2 multiplied by £2.45 is £4.90. So the total profit, for the large mugs at least, is a profit per mug, which we've just worked out above is £4.90, multiplied by the number of large mugs she sells, which is 99. So £4.90 multiplied by 99 is £485.10. So her total profit the grand total, if you like, will be the profits from the selling the small mugs, which is £80.85, plus the profit from selling the large mugs, from which she made £485.10. And so the final step we need to do is to add up these two profits, the profits from the small mugs plus the profits from the large mugs. So if we add these two together, we will arrive at our final answer. So £80.85 plus 485.10. What we should get is a final answer of £565.95. So that's the final answer, which we just put down on our answer line. And that's question 11 done. Question 12, we have to write down integer values of x, where 1, x, 7. This means that x is bigger than or equal to 1. The reason it means it could be equal to is because of this second line underneath the inequality sign. But x must be less than 7. So the smallest value x can be is 1, and so x can be 1. It's allowed to be 1. The second value it can be is 2, 3, 4, 5, all the way up to 6, but it must be less than 7. Integer means whole numbers, by the way, that can be negative if needed to be. So the whole number of values that x can take are 1, 2, 3, 4, 5 and 6, and that's it. X can't be 7, because it's got to be less than 7. Question 13, you have to increase 400 by 37%. And so I'd suggest the easiest first step would be to work out 37% of 400. So we can use our calculator here to do that quite easily. 37% means 37 out of 100. So it's that percentage of 400, which comes out to be 148. Now increase means the amount's going to get bigger. So because we're increasing 400 by 37%, we're going to add on that increase. So the total will be 400 plus the 37% we just worked out earlier, which is 148. So after being increased by 37%, it'll become 400 plus 148, which is 548. And so that's our answer for question 13, 548. Question 14, we're asked what is the maximum number, there are some possible order of rotational symmetry of a quadrilateral. So first of all, quadrilateral means four-sided shape. Now the types of shape which have the most symmetry, whether it be lines of symmetry or rotational symmetry, is the types of shapes which are regular. So regular polygons are most symmetrical. So what's a regular four-sided shape? Regular in itself just means all sides are the same and all the angles are the same. And so what four-sided shape has these properties? It would actually have to be a square. And so a square, the technical name for a square, I would say, would be it's a regular quadrilateral. Or you could even say it's an equilateral quadrilateral. But the street name for that, the cool name, is it's a square. So if you hear it on the street, people say it's a square, but what they mean is it's a regular quadrilateral. So anyway, so there's a square I've drawn. Order of symmetry just means how many times can we turn the shape around so that it looks like itself. So what I've got here is another square just below. And so if we keep an eye on that top right corner which I've put the red dot on, let's see how many times this square looks like itself in one complete turn. So how many times does it look like itself in one complete turn? Starting from where this red dot, sorry, is in the top right. So already it looks like itself once, but it'll look like itself when it gets back to there. So let's see how many more times. That's one time, 2 times, 3 times, and its original position is the 4th time. So it looks like itself 4 times in one complete turn. So the order of rotational symmetry for a square is 4, because I said earlier that the most symmetrical, in terms of order of rotational symmetry, most symmetrical shapes are the regular shapes, which is a square. Therefore, the highest order of rotational symmetry any 4-sided shape can have is 4, because a square is the most symmetrical of the 4-sided shapes, and that itself only has 4. Square's got 4 sides, order of rotational symmetry 4. That will be the same for any regular polygon, by the way. So for example, equilateral triangle, 3 sides, that will have order 3 rotational symmetry. So just a little fact to bear in mind as well, to make it easier in future if you come across questions of this type in other exams. Question 15. Han is trying to work out the size of angle X. So angle X is this angle in the bottom right corner of this triangle. And so he assumes that ABC is a straight line. From A to B to C, he's assuming that's a straight line. What answer should he get? Well, we need to remember that angles that touch at the same point and on the same side of a straight line add up to 180 degrees. And so, put simply, angles that touch together on a straight line add up to 180 degrees. And so if you look at the top side of ABC, this bit's 115 degrees. So this will be whatever's left, so that one plus that one adds up to 180. So the angle at B we can work out by doing 180 take away 115, which is 65 degrees. And so the angle at B is 65 degrees. Now we know that, we can just look at this triangle. Angles in a triangle add up to 180 degrees as well. So because of that, this is 40 and that's 65, so X will be whatever's left. So X will be 180, take away 40, take away 65. So on our calculator, we can just do 180 take away 40 take away 65, which should be 75 degrees. And that's our answer for what X must be equal to. So that's what we put on our answer line. But for part B, in fact, angle ABC is 178 degrees, as shown. So what effect does this have on the size of angle X? It's a 1-mark question, so we just need to make one simple statement. I'll explain why the answer is what it is after. But essentially, angle X will be smaller. That would get you for 1 mark, but you're thinking, well, how do you know that? I'll show you how you can work it out. All around B are these 3 angles, and angles around a point angles around a circle will add up to 360 degrees. And so this one here, now we're told that it's not actually a straight line. The angle at B will be 360, take away 115, take away 178. So the angle at B is actually going to be 67 degrees. And because of that, that will alter angle X. So again, still, angles in a triangle will always add up to 180 degrees. So X will be 180, take away these other two angles. So 180, take away 40, take away 67. We can calculate that simply enough. So whatever's left will tell us the size of angle X. And that's 73 degrees. So compare it to part A, it was 75 degrees. Now we're saying it's 73 degrees. So that's for explanation. But the effect, what we need to put down is just something simple like X will be smaller. To be exact, X has got 2 degrees smaller. But putting something along the lines of just X will be smaller than what it was will do for the examiner. And so that's question 15 done. Question 16, we've got the speed of the International Space Station, which is 27,576 kilometers per hour. We're also told that the station travels 42,600 kilometers in each orbit. We need to work out the total number of full orbits the station does in one day. And so here mentions 1 day. First of all though, we're given a speed per hour. So we've got a different conflict of time here. One's mentioning about days, others mentioning about hours. The question is asking us the number of full orbits in 1 day. So we'd be interested in changing how far it travels in hours to how far that would be in days. And so if a space station travels 27,576 kilometers per hour in 1 day, we could find the distance by multiplying by 24, because it's 24 hours in a day. So if we find this value here, 27,576 multiplied by 24, we get 661,824. That's how far it travels each day. So to do one orbit, it takes 42,600 kilometers. So if it's doing this many kilometers in each day, we can work out how many orbits this number is by dividing 661,824 by 42,600. 661,824 divided by 42,600. Let's see what that tells us. So 661,824 divided by 42,600 comes to 15.53 something. So essentially that's 15 and a bit orbits. So it's not quite 16 complete orbits, it's only 15 full orbits, because we're asked how many full orbits it does. 15 and a bit isn't the same as 16, so it's only 15 full orbits plus a bit extra as well. Part B, we're asked to change 27,576 kilometers per hour into meters per second. So there's two different conversions here. One's saying kilometers, now wanting meters, and hours and seconds are also different. So what I'd suggest doing first is changing from kilometres to metres. And we need to remember that 1 kilometre is 1,000 metres. So if we're changing from kilometres to metres, because this relationship's in the form where one number's 1, the other number isn't 1, we can change from one unit to the other by multiplying or dividing by the number that isn't 1. So we're going to multiply or divide by 1,000. To go from kilometres to metres, we're going from a small number to a bigger number, and so we'll be multiplying by 1,000. And so 27,576 kilometres will equal that number multiplied by 1,000 in metres. We're timesing by 1,000 because of what we said over here. So if we just try that now, 27,576 multiplied by 1,000, we'd get 27,000, the same number effectively, but with 3 zeros at the end, so it changes it from thousands into millions. It's a big number. So it's 27,576,000 metres. And so it can do that many metres per hour, it says. But we don't want to work out in terms of hours, we're wanting seconds. And so 1 minute is 60 seconds. And an hour is 60 minutes. And so if we multiply these by 60, that will tell us how many seconds are in a full hour. So 1 minute is 60. So 60 minutes will be 60 multiplied by 60 seconds. 60 times 60 equals 3,600. And so 1 hour, which is 60 minutes, is the same as 3,600 seconds. And so when we say per hour, what we can actually do is just say per 3,600 seconds. At this stage, we can now, if you wanted, we could use a speed, distance, time triangle. So just to refresh your minds, speed, distance, time. Sausages don't talk is where you can remember it. And that is funny because it's true. Sausages don't talk. So we know here now the distance in the units we're wanting. We also know the time in the units we want. And so the speed, which we want to work out, we cover up what we want to work out. Whatever's left tells us the speed. So it's distance divided by the time. So what we should have is 27,576,000 divided by 3,600. And we get 7,660 meters per second. If you weren't sure about using that distance, speed, time triangle, what we could do instead is just to use this as a ratio and think meters per second means how many meters in 1 second. So just to show you a slightly different way, how could I go from 3,600 seconds to just 1 second? What could I divide 3,600 by to get 1? Well, any number divided by itself would give us 1. And so we can divide the time by 3,600. 3,600 divided by 3,600 gives us 1. But if we do that to that side of the relation, we need to do the same on the other side. So if we also divide this distance by 3,600, what we'll get is the same thing, 7,660 meters per 1 second. So 7,660 meters per second. And that's question 16 completed. Question 17, we have an awkward looking shape over here, and we've been given a method to estimate the area of the shape. And so we put the shape onto rectangular grid of dots, which has been done for us, and we write the number of dots in the shape as a fraction of the total number of dots. And so we can start this by doing step 1. How many dots are in the shape? So this is step 1. So if we just count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you've got 16 dots in the shape. What we need to do as well is find out how many dots there are in total. So 16 dots in the shape, the total number of dots. Well, there's another 4 here, which are on the outside. So 16 yellow ones plus 1, 2, 3, 4. That means there's 20 dots in total. So total dots is 20. So the fraction of dots in the shape as a fraction of the total is 16 out of 20. 16 dots out of a total of 20 fall inside the shape. If you want to, you can simplify that down or get your calculator to do it. 16 out of 20 is the same as 4/5. So step 2, we're going to work out this fraction of the area of a rectangle. So the area of a rectangle is just going to be the length times the width. So for this one, it's going to be 7.5 multiplied by 6. So if we try this, 7.5 multiplied by 6, that's 45 square centimeters. And so what we need to do now is to find this fraction of 45. So either 16 over 20 or 4 over 5 of 45 will tell us the estimated answer to the area of this shape. 4/5 of 45 we can do by using the fraction button on the calculator here, multiplying by the amount we want to find that fraction of. So 4/5 of 45 gives us 36. And so our estimated area of this shape is 36 square centimeters. For part B, we're asked how we could improve this method to give a more reliable answer. So essentially it's asking how could we make the answer more accurate. So what we could do I think the most obvious thing to mention is if we had more and more squares on this grid, we could get a more accurate representation of the fraction of squares on the inside compared to the total. And so we could have a grid with more dots on it. So just put something like more dots on the grid, or a more densely dotted grid. Something like that. For 1 mark, you don't need to give an essay, just a simple statement, just getting to the point that more dots on the grid would help for reliability along. Question 18, we have a graph showing the shop's daily profit over 2 weeks. We need to circle the profit on Tuesday of week 2. So week 2 is the solid line, not the dotted line. So Tuesday of week 2 is going to be this solid line here. So week 2 is this value here. So it's between 160 and 180. So it's definitely not going to be 140. But if we have a look here, the scale, these numbers are going up in 20s. 180 plus 20 is 200. And in between each numbered square, we have 5 little squares. So what we could do is work out how much each tiny square represents. So it's going up in 20s. So each £20 increase on this grid is 5 squares. So if £20 is 5 squares, we can work out what 1 square is by just dividing by 5. 20 divided by 5 is £4. And so each square going upwards represents £4. So for Tuesday of week 2, if we just draw a line across from here, there's 160 and it's 3 squares up. So 164, 168, 172. And so the one we need to be circling is 172. Part B, we're told about the total profit on Mondays. So for 2 weeks, the total profit on Monday was £260. We need to find out which day had the highest total profit for the 2 weeks. So total profit will be the profit for week 1 combined with week 2. So for Tuesday, Tuesday's profits for week 1 is that figure here plus that figure here. For Wednesdays, we're looking at these 2 values, which are very close together. For Thursday, we're looking at this one and also this one here. Friday, this one and that one. And finally, for Saturday, we've got this figure and this figure. So let's just compare them all. So for Tuesday, the total profit for Tuesday is, this one's 140, and this one here we worked out from part A, that's 172. So 140 plus 172, that'll tell us the total profit for Tuesday. So 140 plus 172 would give us 312. So Tuesday's total profit for 2 weeks was 312. Let's now do the same for Wednesday. So on Wednesday, this first one here for week 1 was £120. Now this next one here seems to me to be 2.5 squares up from 120. It's bang in between 120 and 140. So I would estimate that one as being £130 because it's halfway between 120 and 140. Add those two together, we get 250. So profit from Wednesday in total is 250. So Tuesday's still in the lead. Check for Thursday next. So for Thursday, this first value here is 124. And this one over here is 160. Add those two values together, we'd get 284. So again, it's still not as high as Tuesday, so Tuesday is in the lead still, if you like. Let's have a look next at Friday. So Friday for week 1, that's £140. And week 2, the profit's massive, look. For week 2, so I've got my lines mixed up. This one here is week 1 actually. So for week 1, well the second one anyway, that profit comes high all the way up to 200. So 140 plus 200 is 340. So Friday's now in the lead. But will Saturday be any bigger? So let's see for Saturday. For Saturday, very close. So for week 1, the figure for Saturday is £180. For week 2, this one is very high as well, but just not quite as high. That one's the same height as Tuesday's profit for week 2. So that one's £172 as well. So 180 plus 172 would give us £352. And so the biggest out of all these totals is actually Saturday. So our final answer for which day had the highest total profit for the 2 weeks, it would be Saturday. Part C, the manager decides to close the shop on one day each week. So we need to use a graph to decide which day she should close and give a reason for it. Well, we don't want to close on profitable days. So I'm just going to put this inside a bubble. So don't close on days that make lots of profit. That's the main thing to consider. Because she closes on a day where she'd normally make lots of profit, she's going to be turning away lots and lots of customers that may have come to her. So you want to be closing on your quietest day. So going back to part B, the best one to pick would be the quietest day, the day which tends to have the least profit made. So definitely keep open on Saturday because that's busiest. The quietest would be Wednesday. Wednesday is the smallest profit total. So she should close on Wednesday. And the reason needs to be along the lines of less profit tends to be made on Wednesdays than the other days? So she's essentially just minimizing how much money she'd be losing. So Wednesday and a valid reason. For example, less profit tends to be made on Wednesdays than the other days. Finally, part D, Ruby looks at the graph and says Friday, week 1, is 6 squares high. So first of all, let's just have a look what she's saying. So Friday, week 1, is 6 large squares high. But Friday, week 1, this dotted line, is up here, which is 200. She then mentions about Friday, week 2, being 3 large squares high, which is this one here. So she says, so the profit for Friday, week 1 is double for Friday, week 2. Is she correct? It's tempting to say yes, but actually, if we look carefully, she's not correct. So is she correct? No. And we need to give a reason. For week 2, Friday, week 2, profit is 140. But for Friday of week 1, the profit's 200. So is 200 double 140? It's not. No, because £140 times 2 is 280, not 200. The reason it's not worked, the reason she isn't right, is because this graph has got something called a broken scale. So the scale here isn't starting from 0 really. From 0 to 100, that's a different scale than 100 going up. So this part of the graph isn't the same scale as the rest of it. This is going up in 20s, but this first bit we miss out a whole 100. So the reason she's wrong, if you want to know, is because the broken scale means she can't use that idea of proportion. Question 19, we have a kite here, and we're told the perimeter of the kite is 24 centimeters. For this question, we need to know a few properties about a kite, and the first such property is that the opposite sides of a kite are equal. And so one way you could think about it is if we imagine a line of symmetry for this kite going down the middle, then the opposite sides of that will be of equal length. So, for example, if AB is 3, AD will also be 3 as well. And whatever DC is, will be the same as CB. So we need to work out these other two now. And so if the total perimeter is 24, we know these two are 3. Then the other two sides, between them, must be 18 centimeters. If these two are 6, these two green ones must be the other 18. And because these are opposite and equal, that 18 will be divided equally between these two green sides. So 18 divided by 2 will be 9 centimeters. So this one's 9, and that one's 9. And as a double check, what you can do is add up all these 4 lengths, and you would get back to 24. And so the one we need to circle for this one is that the side CD, which is this one here from C to D, is 9. So we need to circle 9, because that's our answer for this one. Question 20. Chris is simplifying 3n to the power 5 multiplied by 2n to the power 4. Identify any mistakes he's made. What I'd suggest we do is just do it properly and just check what we get against his. And so if we're multiplying letters by each other and it's the same letter each time, if we multiply one letter by the other letter, the new power is found by just adding these little numbers at the top. And so n to the power 5 multiplied by n to the power 4, the new power of n would be n to the power 9, because we just add the 5 and the 4 together. And the number at the front, all we need to do there is the 3 at the front of this one, multiplied by the 2 at the front of that one. These big numbers come before the n, and so we need a big number before this n here as well. And 3 times 2, because we're multiplying, will be 6. And so what he should have got is 6n9. So compare what he should have got to what he's actually got. So he put 5 instead of 6. So it looks like he's added the 3 and the 2 together rather than multiplying them. And the power of n should be 9. It should be 9 like we've got here. Not 20. So it looks like what he's done is he's misremembered the rules of these powers. When you're multiplying the same letter and the letters have powers on them, you just add these little numbers. So you add these two, but multiply the big numbers. He's done it the opposite way around. He's added the big numbers, but multiplied the little ones. So unfortunately that's a mistake he's made. But I think the easiest way to tackle that question is to actually just write down what the answer should be. From that, it makes it easy to see where he's gone wrong and to comment on it. Question 21, we've got a sphere here, and we need to work out the volume of the sphere. And we've been given a formula here, luckily. So the volume of the sphere is 4/3, and there's no instruction in between these different things. So what that will mean is these different things here in this formula are going to be multiplied together by each other. So 4/3 multiplied by pi multiplied by the radius cubed. Well, the radius of this one, we've been told the radius is 9. So r cubed in this case is going to mean 9 cubed, because as I said, we're told the radius is 9. So all that's left to do is to carefully input this into our calculator. So 4/3 multiplied by pi. The pi button on this calculator is down here in yellow. So it's shift, that button, multiplied by 9 to the power 3. In terms of pi, the answer is 972 pi. As a numerical answer, we can press this button here and get an answer of 3053.6, roughly. So 3053.628059. So you don't need all those digits on the calculator display, but if you're not sure how to round it, if in doubt, just write this down as the calculator says on the answer line. If you want to round it to something a bit more sensible, what we could do is, for example, round to 3 significant figures, or maybe even just the nearest whole number of cubic centimetres. So to the nearest whole number, that would be 3054 cubic centimetres, because next to that 3 is a 6, which makes this 3 round up to a 4. Part B, we're told about the density of the steel, which is 7.8 grams per cubic centimetre, and we need to work out the mass of a sphere. that's made from this particular steel. So density, mass, we've got the volume. This is a classic case of working out a density, mass, volume triangle. So D, M, and V. So the density we know, the mass we know. Sorry, no, we want to work out the mass. And so whatever we want to work out is what we cover up, and whatever's left tells us what to do. And so we've got D and V next to each other. Two things next to each other in algebra means one thing multiplied by the other. So M will be D multiplied by V. And so the density we've been told is 7.8 grams per cubic centimetre. The volume we worked out previously, which is this figure here. So you can even leave on the answer on your calculator display if you'd like. That's why rounding off prematurely can be a bit dangerous. So if you multiply that by 3054 or 3053.6, whatever you'd prefer. So 7.8 multiplied by that. So we could round this off to three significant figures. That's roughly 23,800. One, two, three significant figures, and change the other numbers to zeros. So 23,800 grams. And that's the final answer for 21 part B. Just be careful not to round too much too soon for that particular question. Question 22, and look at the heading. This one's going to be done in two different methods by me. So the first method I'm going to show you is how to do compound interest a bit slower than a quick way, but the slow way I'm going to show you I think is a safer bet. So if you want to just bear with me for this bit, do listen on and I'll explain how we can tackle this question. So Dev invests £1,500 for 2 years. The compound interest rate is 1.6% per year. Just to make you aware, compound interest is a type of question where the interest changes each year. Simple interest is where you work out the interest for 1 year and then that interest stays exactly the same for each year. Here the interest is going to change from year 1 to year 2. And so what I would suggest we do is we create a table of values ready to be filled in. So it doesn't need to look exactly like this, but I think this is a safe enough bet. So we're going to include the start value, the interest rate, the interest added, and the end of year total. So for year 1, at the start, we're told here that he invests £1,500. So we know for definite that the starting value is going to be 1,500. And the interest rate is 1.6% per year, so we're not told that that changes, so that will stay as 1.6 for all of these years. So the interest that's going to be added, we can calculate by working out 1.6% of this £1,500 we start with. 1.6% we can write as a fraction out of 100. So 1.6% of 1,500 equals 24. I know it's only a 1 mark question, but this is worth doing, especially for part B. The end of year total will be the start value plus the interest. So the end of year total for this one will be 1,500 plus 24, which is 1,524. Now the end of year total for year 1, is what Dev will begin with for year 2. So this total here now moves to the beginning of year 2. So this time around we're starting with £1,524 instead of the £1,500 we had before. The interest rate is still the same, but now we're working out 1.6% of a slightly bigger amount. And so we're doing the same percentage rate, 1.6%, but now, instead of multiplying by 1,500, we're finding 1.6% of 1,524, which comes out to be, to the nearest penny this is, £24.38. And so this total now for the end of year 2 will be 1,524 plus £24.38. So if we just work this out on a calculator, so that's the interest plus 1,524, which we began year 2 with, we get £1,548.38. There is a more direct, quick way of doing it, which I'll show you later, but bear with me for now. So now we know that he gets this much money at the end of year 2, we can simply compare this value to the possible options we need to circle. So which one of these 4 possibilities will equal this? So we can just try these ones on our calculator. But what you should find when you do that is that only one of them will match up to this one, and it ends up being this one here. 1,500 multiplied by 1.016 squared, or you could do to power 2, equals 1548.38, which is exactly the same as what we had here. And so this is the correct answer. This is one we need to circle. Now I'll give you a quick tip. If you are pushed for time in the exam and you want to make an educated guess if possible, for percentage interest questions, for compound interest, the amount is going to typically grow if it's in a bank account, for example, but it's not going to get much bigger unless it's invested for a long amount of time. So as you can see here, this is a fairly typical question. So it took him 2 years, and even then he only ended up with about £50 extra for those 2 years. So the money's very, very rarely going to double. In fact, not in this world, not in 2 years. If you try these other ones here, you should find that the money at least doubles, which is just unrealistic. It'd be great if you could invest £1,500 for 2 years and then it more than doubles in value, but it's not going to happen. So the examiner will try to make the questions as realistic as possible within reason. So the other 3 options, looking at it from a real life point of view, aren't anywhere close to being realistic. So it's this one here. Now part B, we need this value to compare with Emma's investment. So if we just remind ourselves what Dev got, so Dev's investment was 1548.38. So just let's put this here to keep a check of what he got. £1548.38. Now we're doing Emma's investment, so we need to compare Emma's against Dev's. So again, using a similar table, we can do this. This time though, if you have a look at Emma's bank, the interest rate for Emma is going to change. For the first year, the interest rate is 1.8%, but then for the second year, it drops to 1.3%. So just be a bit careful. Again, she's starting off with £1,500 though. So for year 1, we can calculate the interest added to her account by working out 1.8% of 1,500. So let's do this one. So 1.8 out of 100, that's 1.8%. multiplied by 1500 tells us she gets £27 interest in the first year. And so her end of year total for year 1 will be the 1500 she starts with plus the £27 interest, which comes to 1527. This end of year total for year 1 is what she'd start off with in year 2. So year 2 she starts with £1,527, but now she gets 1.3% interest on this value. And so now the interest rate she's going to get is going to be 1.3%, and it's no longer £1,500 because she has an extra £27 in her account. So 1.3% of 1,527 comes to a total, to the nearest penny, of £19.85. So her final total at the end of year 2 is 1,527 plus £19.85. So just checking on our calculator to see what that comes to. 1527 plus 19.85 gives us an end of second year total of 1,546 and 85 pence. So now we can compare Dev's to Emma's. So Dev ended up with £1,548.38. Emma, on the other hand, has ended up with £1,546.85. And so whose investment was worth more? As you can see, it's very similar, but Dev's got more money. He's got about another couple of pounds or so, not even quite that. 1,548 is higher than 1,546. And so those two tables would be your working to support your final conclusion that the person whose investment is worth more is Dev's investment. So just conclude by answering the question and just say Dev's investment is worth more, or just put Dev if you want to save some ink. Now question 22. Previously I've just done the same question using a different method, which is what I called a slow but sure way, using tables. I'm now going to mention the decimal multiply method. Before I do, I'll just give you some notes on this, should you have not come across it before. So it can be split down into 4 steps and is a great way, and a quick way as well, of mastering compound interest questions. So for simple interest questions, you'd never use it. For compound interest questions, for example, bank accounts, it will work, but it takes a bit of time to master. Anyway, let's have a read. So step 1, we're going to start with 100%. So we're going to write down 100% first. If the question is about an amount that's increasing, it's a bank account with interest, so the amount will be increasing. We're going to add the percentage change to the initial 100% in step 1. So 100% plus this change, which is 1.6%, would give us a total of 101.6%. So that's step 2. So step 1, start with 100%. Step 2, we've added on the percentage increase the question is talking about. In this case, it's a 1.6% increase on his account each year. And that gives us 101.6%. And so we now need to do step 3, which is to divide this value by 100. That's how you change from a percentage to a decimal. And so if we just take this value here and divide by 100, that will convert it into the decimal multiplier we're after. I do promise, with practice, this becomes more like second nature, but it does take practice to get there. And the notes make it seem harder than what it actually is. But if you wanted some notes which will work all the time, these notes will do the trick. So 101.6 divided by 100 comes to 1.016. And that's the decimal multiplier. The decimal multiplier here is 1.016. Step 4, we multiply the starting value, which was £1,500. We multiply the starting value by this decimal multiplier once for each time period the amount is changed by that particular percentage. And so because it's invested for 2 years, we're going to multiply by this decimal multiplier not once, but twice, because it's the same percentage which is being changed. It's the same percentage change. It's 1.6% for both years. That can be simplified down further because the interest rate doesn't change. Because we're multiplying by 1.016, then multiplying by 1.016 again for a second time, we can say we're multiplying by 1.016 squared, 1 power for each year. And so for that reason, without even having to calculate it, using the percentage decimal multiplier method, the one we'd have to circle would be this one, the bottom right in this case. So what we can do for part B is actually work out Dev's investment. And so Dev's investment we need to compare with Emma's. So going back to part A, his investment total can be found by doing 1,500 multiplied by 1.016 to the power 2. That's what we did in part A. And so Dev's total investment squared to the nearest penny will be £1,548.38. We now need to compare Emma's investment against Dev's. So for Emma, the interest rate for Emma changes from the first year to the second year. So for the first year, it's a 1.8% increase. So as a decimal multiplier, this will be 100 plus 1.8, which is 101.8%. Divide that by 100, and the decimal multiplier for the first year would be 1.018. And for the second year, same idea, but just different percentage. Once again, start with 100%, add 1.3%. That tells us that year 2's end of year total will be 101.3% of what it started out as. We then need to change that percentage to a decimal by dividing 101.3% by 100. And if we do that, we get 1.013. So for the second year, the decimal multiplier is 1.013. And so for Emma, her investment, £1,500. Now the first year, you're going to multiply by 1.018 only once, because it only stays that percentage for the 1 year. So that's for the first year. And then, for the second year, we're going to multiply all of this again by the new multiplier for the second year, which is 1.013. So if we punch these numbers into our calculator, get 1,500 multiplied by 1.018 multiplied by 1.013, and we get £1,546.85 to the nearest penny. £0.85, yes. So compare Emma's to Dev's. In part A, we said that Dev got about £1,548. Emma's got roughly £1,547 to the nearest pound. And so Dev gets a tiny bit more after the 2 years. So answering the initial question, whose investment is worth more after 2 years? Well, the answer to that is that Dev's is worth more. So what I've shown there is two completely different methods for question 22. The first method is a bit longer perhaps, but I would argue is easier to understand. The decimal multiplier method can get you into trouble, but if you take the time and effort to master it and work hard at it, it can save you time in the long run. And it's just a much more efficient, quick way of doing it. But if you're not sure which one to pick, I would suggest doing the table method, which I showed before this method for question 22. That's the safest one to stick to if you're not sure. Anyway, that's question 22 done and dusted. Question 23, it's algebra again. So we've been asked to expand and simplify x plus 5, x minus 4. And so a method I'd suggest you might want to use, you might use FOIL or a different method your teachers have told you, but what I'd suggest you do is you do the box method. And what this basically means is in any order you write one bracket above the box, and to the side you write the other bracket. And so here, the two brackets we've got, one's x plus 5, so I'll put x plus 5 along the top. Doesn't matter which order you put them. I could have put x plus 5 down here, but because I've put this one along the top now, I'll put x minus 4 down the bottom. And what we're doing, because we're expanding brackets, we're going to multiply these out. So x plus 5 we put first, x minus 4 we put down here. So what we're going to do is just multiply what's above the box by what's to the side of the box. So this first box here will be x multiplied by x, which is x squared. This one here, 5 multiplied by x is 5x. This box, x multiplied by 4, would be 4x. But because that 4 is a minus 4, that makes it minus 4x. And finally, 5 multiplied by 4 would be 20. But because the 5 is positive and the 4 is negative, if you multiply two things which have got opposite signs, if one's plus one's minus, the answer will always end up as a minus value. Now what we need to do is simplify other things in this grid. So we've got x squared, that 5x is a positive, that 4x is a negative, and finally minus 20. And so x squareds can't be mixed with normal x's, so I've only got one x squared, but these x's can be combined. So if you've got 5x's here, and we take away 4x's, we'd still be left with 1x overall. We're not taking away something that's bigger than what we're starting with, so it would still end up being positive overall. 5 take away 4 would still leave us with positive 1x, but because it's just 1x, we don't need to put the 1. And of course the number at the end was minus 20. And so that's our answer, x squared plus x minus 20. Part B, notice how this is only 1 mark. I'll explain how to do it and give you the quick way first. Solve x minus 8, x plus 7. If you've got one x in one bracket, plus or minus a number, multiplied by another x in the other bracket, plus or minus a number, equal to 0, the quick way of doing this, I'll get to in a second actually. What it means is one bracket is being multiplied by the other bracket. So bracket 1 multiplied by bracket 2 equals 0. So if I just colour this first one in yellow and the second bracket in green. This is just telling you where this quick method comes from. So if you're multiplying two things together and the answer is 0, that can only happen if, for definite, one of the things you're multiplying is 0 itself. And so from this, we can say that either b1 equals 0, or the second bracket equals 0. If one of them times the other gives us 0, either the first bracket's 0 or the second one's got to be 0. That's the only way we multiply two things together and get 0 as an answer. Just done the wrong highlighting there. B2 is green, first bracket's yellow. So if the first bracket's equal to 0, that would mean that what's inside the bracket must be equal to 0. So x take away 8, I'd have to equal 0. And if that's the case, we can solve that equation quite simply by moving this minus 8 to the other side of the equation. If we swap side, we swap sign. Opposite of minus becomes plus. So we just have x on its own equal to 8. So the answer is x equals 8. Or, there's a second option over here. Maybe the second bracket was equal to 0. And if that was the case, the second bracket's x plus 7. So perhaps that one's equal to 0. The truth is we don't know which is equal to 0. All we know is that definitely one of them was. So if it's this one which is 0, then x plus 7 would be 0. And again, to solve this, we want to have x on its own. So we're going to remove that plus 7, chuck it to the other side, and if we swap side, we swap sign. Opposite of plus 7 is minus 7. And so in this scenario, x would be minus 7. So the full solution is that x equals 8 or x equals minus 7. A good question to ask yourself now would be, why on earth has it taken him that long if it's a 1 mark question? What I'm trying to do is to show you the logic behind what I'm going to show you now. So this is the big reveal. Look at the numbers in the brackets. Minus 8 becomes positive 8. And that plus 7 became minus 7. That's all you do, but this is why it works. So all you do for these types of questions is swap the sign of the number next to the x inside each bracket. Ask your teacher for a bit more practice or for another example, but these are very easy, hence the 1 mark. Minus 8 becomes plus 8, plus 7 becomes minus 7. So questions of this type, if they come up, are pretty easy indeed. Question 24. Write 225 as a product of its prime factors. So this is one of those factor tree questions. It sounds quite complicated when it's worded like that, but it just means one of those factor tree questions. And I'll show you how your calculator can give you more than a helping hand in a second. So let's assume this wasn't on a calculator paper, first of all. Let's assume you didn't have any calculator. 225, what can I divide it by? The number always branches into two bits. On one side what you're dividing it by, on the other side is the answer to that. So what's 225 divided by 5? I know you're probably thinking it's a calculator, Sean, so why are you doing this? But bear with me, it'll be well worth it, I promise. 5's into 2, doesn't go, it's about 2's left over. That 2's now 22. 5's into 22, we can fit 4. 4 5's are 20, so again the remainder's 2. And finally 5's into 25 goes 5 exactly. And because 5 times 5 is 25 exactly, there's no remainder, and so we're done. And so 225 divided by 5 is 45. Whenever you get a prime number, circle it and leave it alone. So 5 is a prime number, so leave that one alone, but 45 isn't. Because again, we can divide 45 by 5, which should be 9. 5's prime. 9 isn't though, because 9 is a square number. 9 can be divided by 3, which would give us 3. Now you've got primes at each end, there's nowhere else to go, you've finished. The only final thing to do now is to write these numbers in order, multiplied together. So 3 times 3, we can write as 3 squared, multiplied by 5 times 5, which is 5 squared. If you can get into the habit of writing it in this form, it's much better. Longhand, it's this, 3 times 3 times 5 times 5. Just all the numbers you've circled in a row, multiplied by each other. So in power form, 3 squared times 5 squared. So how can a calculator help? Well, depending on the calculator, it can more than help. It helps massively. What you can do, if you notice some calculators have a fact button, if you type in the number you want to prime factorise, in this case 225, press equals. Now what we're going to do is do the fact of that. Fact stands for factorisation. So if you press shift, fact, look what happens. It couldn't be simpler. So there really is a huge incentive for you buying a calculator, taking it seriously, studying hard how to use your calculator, because it pays you back with interest. So the calculator there can tell you more or less what the prime factorisation of a number is. It's well worth knowing. Question 25. We've got angles in different triangles in different ratios. So triangle A the angles in the ratio 1 to 2 to 3. And so angle 1 is maybe one part, angle 2, 2 parts, that one, 3 parts. I don't know which angle's which, but anyway, 1 plus 2 plus 3 equals 6 parts in total. So the angles in triangle A have been divided into 1 plus 2 plus 3, 6 parts in total. Now in a triangle there's 180 degrees in total. So the total for each part will be 180 divided by 6, which is 30 degrees for each part. So for this one we can work out directly the size of each angle. So if each part's worth 30, then 1 times 30 would be 30 degrees. 2 times 30 would be 60 degrees. 3 times 30 would be 90 degrees. And as a double check, do these angles add up to 180? They actually would. Jack's saying the middle number in each ratio is 1/3 of the total. So one of the angles in each triangle is 60 degrees. This is what we're trying to prove. And that's what I maybe should have mentioned before I just got started. But anyway, so for triangle A, yeah, one of them's 60 degrees. That 2 represents 60 degrees. And for triangle B has been split into more parts, the angles. So if we follow the same procedure, one's 4, one's 5, and the other's 6. Do not be measuring these triangles. It does say not drawn accurately, so we need to apply ratio knowledge to solve these. So if we follow the same process for triangle A and add the number of parts up, 4 plus 5 plus 6, that comes to a total of 15 parts. The triangle has 180 degrees as ever, so the total of each part will be 180 divided by 15. That should be 12. But always use a calculator just to be sure. Not 16, 15, 12. So each part's 12 degrees. And so what we can work out here is what each number represents in terms of an angle value. So if each part's worth 12 degrees, then 4 times 12 would be 48 degrees. 5 times 12 would be 60. 6 times 12 would be 72 degrees. So yet again, in this triangle, there's also a 60-degree angle. So what Jack's saying about one of the angles in each triangle being 60 degrees, we've proven he's right, because one of the angles inside each of these is 60 degrees. So is he correct? The answer is yes. And the working we've shown here. So that's why Jack is ultimately correct. Question 26. We have a question about a straight line graph, which we've been given. First of all, we need to work out the equation of the line. Now, I'm sure your teacher will have told you at some point or other, probably several points, the equation of any straight line can be written in the form y equals mx plus c. So I'm just going to rewrite this over here. I've got a slightly bit more space. So m is just a number, a constant number in front of x, and m just represents the gradient, which is the steepness of a graph. And c is called the y-axis intercept. And all that means is it's where the graph crosses the y-axis. And so, to find the gradient, what we can do is just take any 2 points on the graph, and between those 2 points, the gradient is the change in y divided by the change in x. So what we can do here is just pick any 2 points, but I would suggest always pick nice points, so points that lie on points which are easy to read. For example, I wouldn't pick this point here. It's between 0 and 1 and it's 0.4 and 3.2. Try and pick whole numbers. I'd say a nice easy point would be, for example, this one, and perhaps this one up here, or maybe even that one would be a nice point. It doesn't actually matter which points you pick as long as you pick 2 points, and the points you pick are easy to read. So let's have a look here. So we pick 2 points. Let's calculate the change in y between them. So between these 2 points, the change in y just means how much the line's gone up. So for this one, the change in y will be how much has gone up from this point to that point. And so here it was 3, it's gone up to 5. So the change in y is 5 take away 3, which if you want, you could just put is 2. Next we do the same for x. So the change in x just means, well, how far x has increased as well. And so x, to start off with, was 0. It's increased all the way to 4. So if it started at nothing and ended up being 4, then the increase in x must have just simply been 4. So the change in x, we can just say that's 4. So the gradient is 5 minus 3 on top, 4 on the bottom, which becomes 2 over 4, which we can simplify down and say that it's 1/2. So the gradient of this one is 1/2, so m is 1/2. So we can say y equals 1/2 an x, or x over 2 if you prefer, plus c. Now c is where it crosses the y-axis, which is here, because this is the y-axis and it crosses when y is 3. So that's the equation of the line. We've worked out the gradient, we've found the y-axis intercept, so we just put those numbers in. Y equals 1/2 of x plus 3. And that's part A done. Part B, what we need to do now is to work out the coordinates of the y-intercept of the line that's parallel to the line in part A and passes through 4, 1. So first of all, let's have a look at this graph and see if we can find on here whereabouts 4, 1 is. 4, 1 just means 4 along and 1 up. So 4, 1 is this point here. So we can just mark that on. Parallel just means going in exactly the same direction. So what we can do for this one is just do exactly the same line direction. So if I take this line here and just get it going in exactly the same direction, and then move it, so it goes to this point here, we can work out where it would cross the y-axis. Hopefully you can see that it's going to be a negative value, because y equals 0 is higher than where this line is right now. But what we can do to make it even easier is just compare the difference between this line and that line. So over here, for the initial line, that was 4 and y was 5, whereas here it's 4 and y is 1, and so the y values are 4 lower each time. So 3 take away 4 would be -1. And so the coordinates of the y-intercept, which means when we cross the y-axis, will be down here. all you need to realise is that this line is exactly 4 squares lower. So count down 4 squares. 1, 2, 3, 4. So 3 take away 1 is 2, take away another 1 is 1, 0, minus 1. And we know that by comparing these 2 points. This point here is 4 squares below, and because the line's parallel to the initial line in part A, all of the points will be directly 4 below as well. So we can just say here that x is 0. Let's just undo that bit of writing. X is 0. The value of y is minus 1. That point down here. Finally, we've got the last question on the whole paper, which is probably always a relief. So it's talking about a charity collection that was made. And we've got information about the amounts given by men shown in this table. So some men gave between 0 and £5, some gave between 5 and 10, others gave between 10 and 15. The question's been quite nice here because it's prompted you to find the midpoint. We're not told exactly how much any of the men spent, so the best estimate for men in each group, how much they spent, is to take the midpoint of each group. So halfway between 0 and 5 would be £2.50, or 2.5. The halfway point between a fiver and a tenner would be 7.5. I'll just mention, if you're not comfortable calculating these or not sure how to do them manually, you can find the midpoint of 2 different values by adding them together and then dividing by 2. So for this one, 10 plus 15 is 25. 25 divided by 2 would be 12.5. So that's how you can calculate the midpoints directly if you want to with your calculator. So what we've saying here is that 11 men, some spent maybe £2, some spent maybe £4, but 11 men averaged out probably spent roughly £2.50-ish each. So that's £2.50 multiplied by 11 is our best estimate for how much the men in this category spent in total. So what we're going to do is multiply the frequency of men by the midpoint for each group. And that will tell us our estimated total donation. You don't really need to label this, but you can if you want, because it's obvious what you're doing for working here. 2.5 times 11 will be the first row's total. 2.5 times 11, £27.50. For the next row, 7.5 multiplied by 7 is £52.50. You can put 0.50 if you want to, you don't have to. And 12.5 times 2, that should give you £25. So if you add up these totals here, that will tell us the grand total. So if we total all these up now, £27.50 plus £52.50 plus £25 comes to a grand total of £105. So the mean amount spent by the men will be roughly the total amount spent, sorry, not the total spent, the total donated. I'll just say mean for the men. So total donated by the men divided by the number of men that donated. So the total donated we've just worked out. So the total donation from all these 20 men was £105. and we're told in the question the total number of men, which is 20. If we weren't told the total number of men, we could work it out manually by adding up all these numbers in the number column. 11 plus 7 plus 2 would have told us 20 anyway. But now we've got 105 over 20, which we can calculate directly. So 105 divided by 20, £5.25. So that's the mean for the men. Mean for men was £5.25. If you compare that for the mean amount given by the women, that was £6.30. So the question asks us to compare the means for the men and the women. And so there's only one thing we can say really. Taking these averages, if men gave on average approximately £5.25, which is our best estimate, but the women gave £6.30, we can say that on average, or in general, women gave more than the men. And that's all we need to really say as a closing statement for question 27. But the main marks will come from all this working in the table and then calculating the mean. But anyway, that's the paper done now. So that's question 27 done and dusted, and there's no more to say apart from I hope you found some of those questions at least useful. Do feel free to comment, give any feedback, and hopefully I'll see you soon, either in class or on here.